This video is hopefully going to help you when we are just beginning our introduction to functions, which is from section 8.2. So it's a packet of worksheets that I've provided you of fun-filled activities. All right. Remember, for those of you that slept during class, or maybe you were absent, what is a function? Right here, I'm going to just show you what a function is, but it says given a relation in x and y, we say y is a function of x if for every element x in the domain, there corresponds exactly one element y in the range. Now, that may be a little confusing, so let me look at some examples with you real quick. We've got two sets. My first set of x's is called my domain, and the second set is called my range. Now, it is a function if for every element in my domain, each element is mapped to exactly one element in the y, okay? So, for example, this is not a function because you see how this element 1 goes to not only the 3, but it also goes to the 4. That would not be a function by definition. So this one's okay because they're each only going to one element, okay? This one is actually a function. It's fine. They're all going to just one value of y. Okay, it's okay if they all go to the same one. That's a function. You just can't have an x that goes to two different values of y. Okay, so that's just kind of telling you what a function is. Now, when I look at a set of ordered pairs, this one is actually a function. Okay, there's only 3 pairs here, but I can tell you it's a function because notice all my x values are different. I'm going to find one that's not a function. Woo! This one's not a function. Again, if they just give you a list of ordered pairs, do you see how the x value is listed twice? It's got the same x, but yet it goes to different y values. Therefore, this one would not be a function. All right. Now, if you would graph these 4 points, you would find that if you drew a vertical line, these would be right on top of each other. And so let me see if I can find an example for you like that. Let me look right here. Okay, let me tell you this. Look at these ordered pairs. This is a function because do you notice how all the x's are different? And if I would graph those 3 points, I could also tell without even this, hey, this is a function because if I would draw a vertical line straight down, it never intersects. But yet, look at this one. Okay, I can't see the ordered pair, but yet I can tell you it's not a function because if I do the vertical line test, I can see that it's going to intersect in more than one point. And you can see here by the ordered pairs, I can tell it's not a function because they're the same x. See how 1 is listed twice? It's going to different values of y. So it's not a function. So I can tell either by looking at the ordered pairs or I can tell by looking at the graph because it fails the vertical line test. Okay, so again, I can tell by this graph, not a function, because if I draw a vertical line anywhere, if it intersects anywhere in more than one spot, so let me get a pencil out real quick, you can tell if I go like this, it's intersecting in more than one spot. It's okay here, it only intersects once, but if it does it anywhere, it fails. This one would be a function because it passes the vertical line test. So you can see here, that's where they've given me my knots. This one is a function, passes the vertical line test. This one is not, because you can see if I drew a vertical line, it would intersect in several places. Okay, now I am going to do a couple here from your homework about what it means, okay, to be a function and how you evaluate these functions. Let me get a piece of paper out that I can work on. So I don't want to hit pause because it makes me lose it and I forgot your paper. So you're going to go for a journey. Look how green it is outside. It's so pretty. And we're going to get in the junk cabinet. Gotta love it. Gotta love it. This is what I get for not being prepared. But you can check out pickles, mixed nuts, diced peaches. Where's the chocolate? Gosh, I don't even know. Okay, here we go. Pretty flowers. Okay, here we go. That was a little side note. Now, why are they listed like this? Let me just say, in the context, this does not mean f times x. Not at all. You could simply write this as y equals 6x minus 2. g of x. Instead of g of x, you could say y equals negative x squared minus 4x plus 1. The problem is if I've got a bunch of these equations and I was trying to communicate with you and they all were y's, you wouldn't know which one I'm talking about. So that's why we look at it like this, because I say, hey, when I'm talking about function k of x, you would be like, oh, she's talking about this one, okay? So this way you know which one I'm talking about. By the way, look at those absolute value bars. Hey, if I was going to graph that, you should know what that looks like. It would be a sharp V that goes to the right 2 places. Cool beans. Okay, but anyway, these will be all over your ACT. And what does it want you to do? Now, I assigned you the odds, so I'm going to do the evens here just for a minute. So let me find one that I actually like. Instead of doing G of 2, let's do G of 3. So I'm actually going to make one up here. So I'm going to do G of 3. So I'm going to go over here. I'm going to find what function are they talking about? This one right here. So I'm going to go ahead and I'm going to write that on my paper that G of x equals negative x squared minus 4x plus 1. Okay, so what are they wanting me to do? Well, instead of the x, they want me to plug in a 3. So what I'm going to do is everywhere I see an x, I'm going to plug in a 3. So it's going to look like this. Negative 3 squared minus 4 times 3 plus 1. And then I'm just going to figure it out. Remember order of operations, you're going to do exponents first. Okay, so I'm going to get 9. So I'm going to get negative 9 minus 12 plus 1. So that's going to give me what? Negative, I can't even think, 21 plus 1. So negative 20. Okay, and that's your answer. So you would say G of 3 equals negative 20. By the way, this would be your x value. What comes out is your y value. So if I was actually going to graph that, it would look like this. And then it would be the point way down here at 3, negative 20. Okay? So let's try another one. This one wants you to find k of 2. So I'm like, okay, I'm going to go find function k. There it is. And where I see an x, it tells me to plug in a 2. So I'm going to plug in a 2. 2 minus 2 is 0. Absolute value of 0 is 0. So I would say that k of 2, I would write it like this, k of 2 equals 0. That's the answer they want right there. Realize this is your x. What comes out is your y value. Okay? So let's look at another one. This one wants you to find h of 0. Well, when I go find h, here he is, look at this. It says it's 7. There is not even an x there. So it's telling you, hey, I'm always a 7 no matter what. So h of 0 is 7. H of 100 would be 7. H of smiley face would be 7. Love these. These are called a constant function because it never changes. This is a little weird. This one wants you to find f of t. Ooh, that's an odd one. So I don't want to do that one. Let's do this one instead. Let's do g of a. Because I don't want to do your odds. That's what I gave you. So go find function g. Ha ha. There he is. Everywhere I see an x, it just says, well, plug in a boring a. Do not make this hard. So remember, here was g of x. So g of a is going to look like this. Everywhere I see an x, I'm going to plug in an a. So instead of x, it's an a. That's my answer. I can't do squat with that because there's no like terms there. So that's your answer. Weird, I know. Okay? So I'm looking at this next page. Let's do, oh, I just must really like the odd ones for some reason. Let me find one I like. I think I did that one in class. So, did I? I don't remember. Let's do this one. F of x plus h. All of a sudden, we're getting a little weird. F of x plus h. So I'm going to come over here. These are a little more interesting for sure. So go find function f. Here he is. I'm going to copy that down on my paper. It's 6x minus 2. So here we are. So this is saying instead of a boring x, I'm going to plug in x plus h wherever I see an x. So right here, instead of this boring x, I'm going to put in x plus h. So I'm going to get 6x plus 6h minus 2. Again, that's my answer. There's no like terms. There's nothing I can really do with that. So we're not going to worry about it. Maybe we should do one more here. Let me do a 36. 36 is actually, I think I did this one in class, but I'm afraid you'll have one like this again, or you'll have it like on the ACT. Because g, the function g, is actually the most difficult one because it had a square term in it. So let me write it back down so I don't forget it. You're still doing this the same way. Everywhere you see an x, I'm going to plug in x plus h. So I'm going to have x plus h squared minus 4x plus h plus 1. Okay, remember we're going to do exponents first. So I need to square this. I'm going to put that negative out front so I don't forget. So that's x squared. And everybody always remembers the h squared on the end, but don't forget there's a middle term. When you do x plus h, I'm going to do it over here on the side, times x plus h. When you do your outside terms, do you see you get xh? And then you do your inside terms and you get xh. So you get 2xh for your middle term. So do not forget that. I had to squish him in there. Okay, don't forget this is a negative 4, so you're going to distribute that in. Plus 1. So this negative on the outside is going to change all my signs. Minus h squared minus 4x minus 4h plus 1. Okay, you talk about a wicked answer. That's it. They love to put those on the ACT, okay? Because they're mean. They're wicked. All right. So what else is on this worksheet that I'm wanting you to do? These are the most simple things, and you're going to love them. But first of all, let's look. Is this a function? It tells me a function. So yes, but why? Notice all my x values are different. What about q? All the x values are different. So yeah, they're functions. You can't play the game if it's not a function. Okay, let's just do this one because I can see it. It says go find function p. This is my function p, this set right here of ordered pairs. It wants to know if my x value is 1/2, what's the y value? Well, look, here my x value is 1/2, the y value is 6. So my answer to this is simply 6. Okay, look at this one. It says go find function q. Here's q. This is this set of ordered pairs. It wants to know if x is 0, what's the y? Right there, 9. So simple, simple, love it. What if I would have said this? I like to go backwards. If, I'm going to make one up here, p of x equals 2 pi, then x equals what? Okay, I'm going backwards, which they're going to do to you here in just a little bit. I'm looking for the x. I tell you the y. So it's a p. So you're going to go find function p. Here's function p, the set of ordered pairs. I tell you the y value is 2 pi, which there it is. There's the y value, it's 2 pi. So my x value has to be 3. So x is 3. Okay? Easy enough, easy peasy. Okay, that's an odd. Definitely don't want to do an odd. What if I've got a graph? Look at my little graph here. They call this my graph function g. Okay, you would say y equals g of x. Remember, this is the same thing as y. So basically that says y equals y, which is ridiculous. It says find g of -1. Remember, this is my x value. It wants to know the y. So what I do is I come over here to -1 and I look at that point. Do you see that's the point -1, 2? This point right here. So this value right here is 2. Okay? I'll do another one. It wants you to find g of 1. So go find the point over there on the graph that is 1 something. I'm looking for the y value. So look right here. This is the point 1, 1. So the x is 1, and it just so happens the y value is also 1. G of 4. Go find 4. There it is. And it would be 1 because that's the point 4, 1. So I love that. Now these are what I'm talking about that's a little bit more interesting. It says for what values of x is g of x 3? Well, it's telling me the y value is 3. So look up here. Here's the y, and the only thing that has a y value of 3 is this point right here, and I can see that the x value is 2. So here, x would be 2. Okay? Now, one last thing we're going to cover real quick is it talks about the domain. Domain are your x values, and it wants to know how wide is your graph. No, the furthest point to the left is -3, so my domain would be -3 all the way to 4. I'm almost done. And then my range, your range are your y values, and it wants to know how high and how low does it go. Notice the lowest value is right here, and that y value is 0. So it goes from 0 all the way up to 3. So my range would be 0 to 3. That should give you enough to get started. Enjoy.